Let us now start our discussion with two-port network. So the very first thing that you should know here is what is meant by a port. Okay. So a port is nothing but a pair of terminals through which the current may be leaving or it may be entering. Pair of terminals through which current may enter or leave a network. So that means, let us say you have some resistance, capacitance, some inductor, another inductor here, and you have a voltage source here, and then you have a current source here. Now all of whatever the circuit it might be, if you are able to just remove two terminals, okay, out of this entire network, then this pair of terminals is called as the port. Okay. If there is only one port, then we call it as single port, and when we have two ports, then it is called two port. If there are n number of ports, then we call it as n port. Okay. So if you draw the example of a single port network, we draw the Thevenin's and the Norton's equivalent, right? So how do we draw that? The entire circuit we take and we represent with the Thevenin's equivalent, and we take out two terminals. So this is a single port. Then what about two port networks? This is our discussion here. This is our point of discussion here. So what happens here is you have a network. On one side there will be one port, and on the other side we will take another port, and often we name them as input port and the output port. Okay. So you can write here input port, and this we take as the output port. Okay. Now the voltages at input port we can take as V1, at output port we can take as V2. What about the currents? The currents we take them to be entering on either side. Okay. So in input node also current is entering, output node also current is entering into the network. So this current direction is very important here. Okay. Now what about an n port network? N means n number of. Okay. So that means if you have a network like this, so you have one port here, let us say this is port 1. Here you have another port, port 2, and so on till n number. That means we are just making use of a variable here. N can be 1, n can be 2, 3, 10 as well. Okay. So this in general we write as n port network. Now our discussion is this two port network. Okay. So what are the variables here? V1, V2, I1 and I2. So we have 4 variables, and these 4 variables, out of these 4 variables we take 2 variables as independent. Out of the 4 are independent variables, and the other 2 variables will be dependent on these independent variables. Other 2 variables are dependent. Okay. So taking 2 variables as independent and 2 variables as dependent, we can characterize the two port network. What is meant by characterizing? So characterizing is nothing but to be able to describe the behavior of this particular network. That's all, nothing else. Okay. So depending on the variables that we have 4 variables here, any 2 variables we can take as independent, any 2 we can take as dependent. So depending on which one is independent and which one is dependent, we have various kinds of parameters. What are the few parameters? ABCD parameters we have, the Z parameters we have, Y parameters, which is also called as admittance and impedance parameters, Z and Y, right? And we also have H parameters and the inverse H parameters. So these are all the various parameters that we will be finding out, we will be knowing about in this discussion of two port network.